Okay, hi there. Today, for Algebra 1, I'm going to be doing a review for Test 7. So I'm going to buzz through about 10, 11 problems, something like that. All right, so the first thing is if I have an exponent problem like this, and this whole thing is really on exponents, this whole chapter. If I take something to the second power and have a fraction in there, you can take both the numerator to that power and the denominator to that power. Okay. Now you might see that as your answer. If you wanted to, write down that 6 squared is 36, that's fine also. Either one of those would be great answers. Okay, so that's all there is to that. Second, this one, I've got several things to combine here. First thing I'm going to do is multiply my regular numbers together. So I got a 5 and I got a 3. If I multiply those together, I get 15. Next, I'm going to add the exponents up on the y's. You got to remember that the exponent on the y, if there's nothing written there, has 1s. All right, so I add up the 1, the 5, and the 1 gives me 7. And that's the answer, 15y to the 7th. Okay. Next one. This is multiplying two things together that have the same base. So you add the exponents together. It just happens that they are 7.23. And then 5 plus negative 5, of course, is 0. So I've got 7.23 to the 0 power, and hopefully you're remembering that anything to the 0 power is actually 1. The only exception is 0 to the 0, which you don't see very often. All right, so that's the answer. Next one, I got some negative exponents. Because I got that x to the negative 5th, in order to make that a positive exponent, I'm going to move it to the top of the fraction, or the other part of the fraction, which in this case is the top. The 8 has a positive exponent of 1 implied, so that stays where it is. And the y has a positive exponent, so that stays where it is. Okay? And that's it. I'm just leaving my answer like that. Next one. A little trickier. This one has parentheses between the exponents, which means you don't add them, you actually multiply them. So I'm going to multiply j to the 1/4 times j to the 2/3. And hopefully you remember that multiplying fractions is easy. It's adding and subtracting them that's hard. So if I multiply those together, I multiply the numerators together. 4 times 2 is 2. Sorry, 2 times 1 is 2. And 4 times 3 will give me the denominator of 12. And then I can reduce that fraction. They're both divisible by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. And there's the answer. Okay. This one, a little more to it. So these two are a power to a power. There's parentheses between them, which means you're going to multiply them. So negative 4 times 2 is negative 8. And then I have the x to the 3rd left. So now I have I'm multiplying, there's implied multiplication there. Multiplying two exponents that have the same base, which means you add the exponents together. Which means I'm going to add the 3 plus negative 8, and you'll get negative 5. Now you're not done yet, because no final answer should have negative exponents in it, which means you have to move it to the other part of the fraction. Right now it's over 1, so I can move it to the bottom of the fraction, make the exponent positive. If there's nothing left in the top of the fraction, you can always put a 1 there. So that's my final answer. X to the negative 5th is 1 over x to the 5th. Next one, scientific notation. So with this, I'm going to multiply the front numbers together, and then I'm going to add the exponents together. So I'm going to add the 5 and the 4. This gives me 9. 4 times 5 for the front numbers will give me 20. Multiply those two together. Now that's not in correct scientific notation. In order for it to be in correct scientific notation, the decimal point needs to get moved. Okay, so that front number should be between 1 and 10, and not 10. It should be a single digit number, which means if I move it 1 to the left, I will get a number between 1 and 10. When you move the exponent to the left, you add to the exponent on the 10, which will give me 10 to the 10th, and that's your answer. Next one. This one, chock full of negative exponents. So anything with a negative exponent, I'm going to move it, okay? So let's start with this one here. So if I move that down to the bottom, make the exponent positive. Now the second one, that one's already got, that's the only positive exponent out of the bunch. So I'm going to put that in the bottom also. Just leave it where it is at the moment. Okay, next, if I got that x to the negative second, in order to make that positive, I have to move it to the bottom. And last but not least, I've got this x to the negative 11th. In order to make that positive, I'm going to move it up to the top. Okay, so now I'm over here. Next, let's see, so y to the 4th and y to the 4th, you can add those two together. It gives me y to the 8th. And I'm good with that. Next, I've got, I got this one where it's, I've got 11 x's on the top and 2 on the bottom. So I can actually subtract the exponents, or you could expand it out. Okay. And remembering when you divide exponents with the same base, you subtract the exponents, which gives me x to the 9th over y to the 8th. Now you could also have done this thing where you start expanding. I've got 11 x's on the top. I don't think I'm going to get all the way to 11, but and I got 2 of them down here. So these two cancel, would leave me 9 more on the top, which would give me x to the 9th. Notice how that's another way to get to the same x to the 9th. Okay, anyway. Rewrite in radical form. Okay, so the x, what's the exponent on the 3 if there's nothing written there? An implied 1, which means it stays outside the radical. It just stays over there. This is the part we're dealing with. So remember, the x goes underneath, and the numerator is the exponent, and the denominator is the root, or the index. Okay, so that is what the answer is. Okay. This one. Does this table represent linear or exponential functions? So a reminder, if I'm going down the y column and you add or subtract over and over again, then it's linear. If you multiply or divide over and over again, it's exponential. So let's see if we can figure out what's going on with the y column. The x column is just going up by 1s. So 2 to 6, what'd you do to get to there? Well, you either added 4 or multiplied by 3. To get to 6 to 18, you either added 12 or you multiplied by 3. To get to 18 to 54, you definitely multiplied by 3. So since I multiplied over and over again, this is exponential. Okay. 11. Find the balance. $60,000 principal earning 7% interest compounded monthly after 3 years. Okay, so they gave me this formula. P is the principal, which is 60,000. R is the rate in decimal. Remembering that 7% is 0.07, so that's what my rate is. N is how often it's compounded, which is monthly, which means it's 12. T is the number of years in time, the time in number of years, which is 3. So now if I take those numbers and I plug them in, I get 60,000 times 1 plus R is 0.07 over N, which is 12, to the 12 times 3. All right, now it's calculator time, okay? I start with the 0.07 divided by 12, then add the 1, all right? And then you get 1.00583 repeating. This is 12 times 3 is 36. Remember to do the exponent first. So next I'm going to take my calculator and I'm going to take this to the 36th power. It would be a good idea to bring a calculator to that test so that you don't have to go 1.0583333 times 1.0583333 36 times in a row. So I get 1.2329 approximately, rounded off, and then it's times 60,000. So if I times by 60,000, I'll get my answer of 73975.54, which is $73,000. Okay. Okay, last problem. A population of crickets is given by the equation y equals 200 times 1.5 to the x, where x is the number of months. A, is this exponential growth or decay? And B, how many crickets will there be after 4 months? All right, so the first part is pretty straightforward. They're asking, is it growth or decay? And if you remember, this number right here determines whether it's growth or decay. If that number is bigger than 1, it's exponential growth. If it's between 0 and 1, it will be exponential decay. All right, so that's the first answer. I already got that one. So it's exponential growth. Second part is how many crickets will there be after 4 months? So I'm going to take that same equation, and I'm going to plug in a 4 where the x is, okay? Because x is the number of months. It's the time. So if I take that same equation, y equals 200 times 1.5 to the x, and I plug in a 4 where the x is, then I can find out how many crickets there'll be. All right, so I'm going to take 1.5. You do the exponent first, always, okay, by order of operations, which gives me 5.0625. And then I multiply by 200, and I will get my answer of 1,102.5. So I started out with 200 crickets. Reminder that that's the initial amount. That could have been easily a part of the question as well. So I started out with 200 crickets, and I ended up with 1,012 or 1,013. Okay, and that is all I got for today. I'm going to close it out with another extra music thing. Have a great night. Good luck on your test.